Hello, welcome to the discussion on Introduction to Microprocessor. In general, when we speak about any computer-like device or any processing device, the brain of that device will be always a processing element, which we title under a name called microprocessor. With respect to academics, if we move on with microprocessor and their versions and their popularity and their operations, one of the selected microprocessor in this discussion would be Intel based product Intel 8085 microprocessor. So moving on to the discussion, if we start from the very basic representation of a computer diagram which we are taught in our school days, saying like a computer block diagram will be having three units: input unit, output unit, and they are linked using some central processing unit. The constitutions that we observe in this central processing unit are arithmetic and logic unit, then control unit, then memory unit. If we see the combination of these three blocks, this is what the discussion of our subject raises. This is what raises for the microprocessor concepts. So in general, if we go in a very traditional way, whenever we learn about any microprocessor, we go with the meaning of the device called microprocessor. What is microprocessor termed in very generalized way? What is microprocessor termed in some technical way? What is microprocessor term based on its operation? So if we start the discussion leads us to the first meaning, saying like, what could be the definition of a microprocessor? We could add to our discussion saying like, we have some multiple meanings of what we want to represent. In very generalized way, if we say a microprocessor is a programmable logic device which executes digital data. This simple line has lot of meanings to be analyzed. It is digital data, nothing but input is binary there and output is also been expected to be in digital, and it is totally programmable in the sense it needs some memory, it needs some storage internally, and it needs some operating elements inside that. Then it needs to work on some ideological logic. It needs to follow certain pattern for execution of data. So a small PLD microprocessor is a programmable logic device which works on a digital data. So if we go with some textbook terminologies or most technical relevant definition, we would like to say like microprocessor is a programmable clock driven register based electronic device which takes in data from some standard input devices then and operates the device operations, programs the program, then it is going to generate a result and deliver this result through some standard digital output devices. Microprocessor is stated as programmable clock driven register based electronic device which takes in data from standard input devices, processes the data according to the stored program in the memory, then produces a result to generate and produce it outside through some standard input devices or store it in some standard memory locations. Another simple definition that we would like to project with respect to microprocessor is a programmable logic device that manipulates or processes data is called microprocessor. Out of multiple names, multiple meanings, what we see even in the previous representation, we would have shown memory unit, control unit, and ALU. A simple microprocessor will have a design constitution of ALU inside that. Then it will have some buses, some IO lines which could act like control unit for that. Then it will have some local storages like memory cells which we otherwise called as registers, data registers, address registers, few inbuilt within the architecture itself. Then we can say it also has some memory elements. So inside the processor architecture we will find ALU, we will find CU, we will find a part of MU. Together we can consider it as a CPU on a single chip. Mostly non-technical definition, but meaning is very deep to understand. So in this regard, if we start learning about microprocessors, what is the procedure we have to know? If we want to learn about any processing devices, what are the things we have to basically concentrate. So before moving on its design, what is the major task of any microprocessor is to perform execution, and how this execution happens is obtaining the data, nothing but fetching the instruction, fetching the data, analyzing what to do with the data, and nothing but decoding the data, then after that performing the execution of the instruction. So if we want to learn about how all these things are happening through a microprocessor, we need to go through its features and its inner discussion. So how it generally represents to us. Basic features. When I say I want to know about some microprocessor or some microcontroller, what are the things we should know is how much data can it handle, or how much external data can it get through memory elements. To operate any memory, we need to generate address, then obtain the data. And how can we access, or how much we can access the memory? At what speed we can easily get the data from memory or IO devices and operate. So these are some of the things that highlight the basic features. Like I want to know about Intel i7, I want to know about Intel i3, I want to know about Intel i5. What are the few things we should definitely know about these differences and these features of any microprocessor at advanced or basic level are something that are listed here. We can designate the microprocessor using its ALU size or data bit size. Then it will be having some constitution of address bits based on which it is going to access some size of memory. Then its operating speed called as clock frequency. Along with that, definitely will be having its physical appearance. Generally we will find it in DIP procedure, dual inline package, and some advanced designs like quad inline package. Dual in the sense we will be having some IC model arrangement on the either sides. If it is a quad, we will be having a square shape given in 4 sides. It will be having some distribution of chips. This could be QIP, this could be DIP. So some structure, some shape will be there for the microprocessor chip. So how many pins it is utilizing for its architecture also matters with the features. So if I want to know about any selective feature, any selective microprocessor, I should at least have a knowledge on these basic features. So with respect to this, if we put this as a common point of discussion, we can move further with one selected microprocessor for our discussion. So one such selected microprocessor is developed through Intel Corporation. So we have a lot of other popular and commercially successful and most useful microprocessor also. In comparison, the leading company Intel has produced its products somewhere around in 1970s, early 1980s or late 1970s. The product development has started. So we are selecting basic structures, basic designs, basic microprocessor architectures for our discussion, starting from the early designs. If we consider the latest design, what is running in microprocessor, Intel Corporation microprocessor, we can say some names easily: i3, i5, i7. If we streamline this, somewhere in the early cadres we have 8086, 80486. Then above this we have Pentium. Then also in the same streamline we will have 8085, 8080. Most commercial successful processors are these two for our discussion, 8085 microprocessor. So we are presenting a discussion on the details of Intel 8085 microprocessor. So one of the short notation of writing microprocessor in smaller way is MUP, microprocessor. So let us go with that. So the discussion presents about microprocessor 8085. So if I want to know something about microprocessor, what are the things I should start with? So as mentioned in the earlier slide, definitely we have to show with respect to the features. What are the features of 8085 microprocessor? Now something gets added to our discussion. It is designated as, it is an 8-bit microprocessor. 8-bit will be designated based on its ALU data capacity. Then According to the design of 8085, it is already structured device through which we can learn and operate. It is already a programmed logic device through which we need to give necessary inputs and outputs and operate. So we will be generally having PLDs. Before PLDs, we will be having ASICs or semi custom FPGA devices. Then we will be having full custom FPGA device. This all deals with the VLSI technology and it is custom design. Then this is where we are going to deal with the application level arrangements. So with respect to 8085, if we come back, it is an 8-bit microprocessor. It has a capacity of 16-bit address lines, and somewhere we can utilize these two representations, D for data, A for address, and few simple lines can be utilized for both operations. They can be multiplexed. Using 16-bit address lines, it can go up to 2 power 16, 64 KB of external memory can be accessed, and the speed that 8085 works is ranged from 3 to 5 megahertz, and its pin structure is represented in a 40-pin dual inline package arrangement. So was 8085 the first microprocessor in the history, or 8085 is the current microprocessor running in the history? No, we have a streamline. So before going in deep, if we just have a look on evolution of this Intel family, what is all we are mostly popularizing is 8085 and 8086 here, according to our learning educational purpose. Anyhow, the first processor that was developed through Intel family was 4004 Intel, and it was having a capacity of 4-bit. At each difference in the model, at each an improvement in the model, we are seeing some new versions. So we can see a simple deviation from the earlier version. Frequency is increased, address lines are increased, accessible memory is increased. So a newly designed or newly improvised earlier version is now titled with a new name. So we can see a gradual increase in the feature representations, which will lead us to some latest names. Even Pentium is a very old name. From this we got dual core, core 2 duo, and what we are using now in the market as i5, i7. All these are all in streamlined with the Intel products. Okay, coming back to 8085, I want to know, if I want to learn more about 8085 microprocessors, again, what are the representations we need to keep in mind? The same representation, again, we put it on the screen here, showing like 8-bit, 16-bit, and 8-bit data capacity with respect to data access arrangement, then addressing capacity 16-bit, then addressable memory based on the amount of address lines we can access, we can go up to 64 KB, then its operating frequency and pin structure. So before going for any design in detail, let us see the basic thing. If I want to consider microprocessor as some processing device, what is a major thing it has to constituted and it has to be built up with is execution unit. The duty of a processor is to process or manipulate or execute. What are the minimum requirements we should have for executing data is we need to have some simple storage, a register set, so saying like as MU, a control unit, saying a set of buses. All these together constitute as a CPU. So what we just mentioned, saying like a microprocessor design is also titled with another simple definition, which is non-technical totally. We consider it as CPU on a single chip for us. So if we look into the inner side of this execution unit, control unit, register set, we would have some inner discussions. A major part that relies over the processing section is arithmetic logic unit. In support to this ALU, very near to ALU will be having some data registers and decoding section. The nearest registers to ALU, we title them as processor registers, and the analyzing part which is nearer to the ALU, we consider it under execution section itself. We call it as instruction decode area. And some flag operations or some status indications will also be presented the ALU instruction execution part. Similarly, we can focus on clock provision, power supply provision through control unit. Then we will be having some registers which could direct us with address operations and data operations. Now we can see how the things are present inside. Now if we want any sort of external interaction through memory or IO, we can see this arrangement. We have a 16-bit address line provision saying like address is always unidirectional and data 8-bit provision is there, and data is always bidirectional. This is a very simple instruction we have to remember in the learning stage. And we would have we could also have look on some more lines that we could be shown here saying like a fat bidirectional indicates more than 1 bit, and mostly it is used for parallel communication. If a fat unidirectional is given, it is considered as more than 1 bit. So it could be 8 bits, 16 bits, 24 bits, 32 bits. We don't have any restriction with that, saying like according to our design requirement, we show the representation. The counterparts of this can be seen here. Individual bit but bidirectional. Individual bit only unidirectional. So the sizes are, the fatness and thinness of the lines help us in identifying what is that we are showing. Then we can get familiarized with this word called AD, address and data. We have a capacity of data lines from D0 to D7, where 0 will be treated as the first position and 7 will be treated as the 8th position. Similarly, for addressing also, the first location will be A0 and the 16th value will be A15 for us. So we will be having 16-bit address lines here. So those address lines are represented in this pattern. So what we see here is this 0 to 15 data lines and address lines. So with this idea, if we move on to the next level indicating architecture of 8085, we just focused on a box saying like what is a major constitution that we should find whenever we learn about the microprocessor architecture is ALU. With respect to 8085, it is 8-bit. With respect to any learning architecture, if we start from ALU, it will be easy for the user or learner to understand how the architecture is planned. Now, what are the things we require for ALU is data, and how can we obtain this data? Through some nearby processor register. One of the most prominent processor register we could get addicted to is accumulator, in short represented as A register. Now accumulator can get connected to ALU along with some temporary arrangements. So together we are creating some buses, some storage, some ALU. So together we can consider this as a CPU arrangement. Then as mentioned in the basic representation, we can't store the complete data in these two 8-bit registers. So at that time we are going to take the help of some external storages, saying like IOs are memory elements. This is the way we are going to address that. Then every time we can't go out and get the data, so we create an internal storage to some little bit extent. So we have some support registers which come after the name A, B, C in combination, D, E in combination, H, L, higher byte and lower byte in combination. They can also be used as individual registers along with the support of some addressing registers for stack operation, program counter operation, incrementer and decrementer of address operation. Together these are considered as register set to us. So whenever instruction is fetched through IO or memory locations, it is been given in the temporary storage here. Then before going to execution unit, it is traveling through some decode area, and this is the instruction decode area. To operate all these things in sequence, we are providing with some clock generation and control units. So what we see on the screen are clock operations, what we require 3 to 5 megahertz, then power supply, then some of the most prominent pins like reset, ready, status operations, input, output through memory operations, hold and hold, HLDA, some buses sharing. And along with that, we are going to see these fat lines, unidirectional or bidirectional, indicate parallel communication. So in the architecture, if we only show parallel communication, we would not be sufficient with that. We need to show a serial communication arrangement also. The design of any processor is incomplete if we don't have a most prominent part called as interrupt area. So together all these blocks, when they mix up with each other, they constitute to become an architecture design. With respect to 8085, we have focused on ALU, then registers, then obtaining it from external sources, then preserving it in, then operating it through a proper procedure. But actually in true, what happens is the very first thing that should generate is power, then clock, and from clock fetching, and from fetching analyzing, and at the last we will go for execution. So though we learned it in reverse way, the representation always show like this. What is that? The very first thing that happens is power generation and clock generation, then obtaining of our information. This procedure is termed as fetching and decoding of the instructions. The last thing that happens inside this is, if no interrupts are being generated, execution will happen. If some interrupt operations or special operations are to be taken in concentration, the interrupt control will awoke and it is going to interact with the CPU operations. So on the whole, what we see on this representation is a architecture diagram of 8085. So it's further discussion we shall take in the continuation. So we stop here and we will continue with the next discussion on details of pin diagram and architecture of 8085. Thank you for joining the session up to here. Thank you very much.